Hi everyone, my name is Eugen. I'm a video game developer and an authorized Unreal Engine instructor. Today I'm going to show you how to work with scriptable tools. This year I fell in love with them and it's really fascinating way to improve your workflow and extend Unreal Engine capabilities for your own project. The main point of this tutorial is to show you how to work with scriptable tools. There are many tutorials about it, but often they miss helpful tips which can speed up your workflow and improve your results. My main goal today is to show you some additional steps you can take to improve your workflow. Also, keep in mind that this tutorial is for intermediate Unreal Engine users and I'm not going to cover basic topics here, assuming you already know about blueprint, events, variables, and so on. So, what are we going to make? We're going to make a garbage generation tool, which will generate garbage from selected assets, merge the result into one static mesh, save a preset, and provide some extra helpful things for us. The tool looks like this. This is like a finished example. It has two buttons. We can add selected meshes from content browser to current category and merge spawned meshes. The tool basically traces the world and places a preview mesh in target location. We can switch between different categories. We have three categories like ground meshes for like cardboards, paper, and things that lie on the ground. Second category is small items. And third category is big items, like boxes, tires, and so on. So basic workflow is we place some meshes, with small boxes, probably this big box, maybe some more boxes. These all static actors created in the level. After that, we press merge button here or here to demonstrate different possibilities or just close the tool. And the result is one merged static mesh. Another extra thing we're going to cover is how to work with content browser. We can get the selected assets and by using one key, just add them to required category. Same with second set of assets and the third group of assets. Basically, you can pick them hand by hand or through search, but when you have hundreds of assets, if you're using asset pack, for example, it's way easier to just pick them in content browser and parse the results into the needed array. So let's begin. Our first step is to enable Scriptable Tools plugin, along with Scriptable Tools framework and geometry scripts. To do that, we go to Edit, Plugins, and enable free plugins here. Scriptable Tools Editor Mode, Scriptable Tools Framework, and the last one is geometry scripts. This one. So enable them and restart the editor. After restarting the editor, you will have access to Scriptable Tools. You can go to this part and select Scriptable Tools. In this list, you will see all available Scriptable tools. Probably you have none, so let's create one. So first, let's create a folder for our Scriptable tools. And after that, go to Blueprint, go to All Classes, and we need Editor Scriptable Modular Behavior tool. This one. This will allow us to add different behaviors like input handling and modes for our tool. Let's call it garbage generation tool and open the blueprint editor. Okay, so this is the editor for our tool. Let's rename it. We can go to class defaults and use long name to give this tool meaningful name. Spawn garbage, probably. Garbage, sure. Compile, save. Let's go to demo map and we can see our scriptable tool available here. It doesn't do anything, so let's fix that too. Go back to the editor and we have to override function. On script setup is basically begin play for scriptable tools. where we can do our initial logic. First of all, let's set mouse behavior. We need to use mouse hover behavior, add it to our tool, and handle hover event from it. To do that, we drag from here, add mouse hover behavior. And we have this begin hover sequence hit test. By binding event to that node, we can enable hit testing and save a result. And this will handle most of our needs for this tool. So let's create event. And from here, create a matching function. Call it handle mouse hover. In our handle mouse hover, we need to get a hit result from mouse position in the screen. So to do that, we're getting current position, break it to input device array, get world array, and get array start end. This is a function which is called from Geometry Scripts plugin, so if you don't have it, please check that plugin is enabled. Next, we need to make line trace by channel. Just a simple one. Start point, end point, trace channel visibility. Actors to ignore, we don't have anything yet, but we're going to use it. And we can probably draw debug for one frame. Connect everything. Can either make or split the output. We don't need anything out of it, but we need to return true here. So we can actually check that how our behavior is handled and can be executed correctly. Basically, we can just drag our return value from line trace to here. Now, if we get back to our tool, spawn garbage, and you can see the small red icons, which is our hit result. Not icons, obviously icon. So you can see it hits walls, it hits objects, so everything works decent enough. We also probably need to save our hit result because we're going to use it. So let's just promote it variable. That's it for mouse handling. Next, let's make a simple preview actor, which will allow us to see the mesh which we're going to spawn. For that, on script setup, let's create spawn actor. Static mesh actor. Transform can be anywhere, we don't really need it. Just let's make empty transform. And this actor should be saved as our preview mesh. Let's set some static mesh for now. So we'll be able to see it. Please. Now, if we're going to our tool, it spawns a mesh. Next, we probably need to align this mesh with our cursor position. We have hit result for that, so let's add another override for script tick. And here we'll just check if our preview mesh is valid. set actor location, get our hit result, break it, get the location from it, and that's it. Now, launching tool, we can see this amazing problem, and let's fix it. Basically, when we're doing hover test, we're hitting the spawned object and adjusting the hit result because of it. So we can just add it to ignore list. Make array, add preview mesh here. Another possible solution is to disable the collision for spawned actors. Now it should be better. Yeah. You can see the problem here, like a second problem, that our meshes are not getting destroyed after finishing. So let's fix that too. Let's override script shutdown. This is basically when our tool is finished. And if mesh is existing, just destroy actor. So we're working with the tool, we finished, actor is destroyed, everything works fine. Next, let's actually spawn something on mouse click. Clean up here first. And think this is our initial mouse handling. For handling click, we'll need to add another behavior. You can see there are a lot of different behaviors like single click, drag, hover, wheel, sequence, and so on. So basically you can do pretty advanced tools with it. For our case, we're going to use single click behavior. So from here, we need two events, if hit by click and on hit by click. Let's connect it and first handle if hit by click. Create event, create matching function. Let's rename to click check. And we actually don't need to do anything specific here. And just split the result, get our hit result here, split it too. And if there was a blocking hit, just pass it here to return value. So the click check is completed and we can proceed with on click event. Second event which we are going to handle is on hit by click. Same create function, and this will be called spawn object because this will actually handle the spawn of object. So spawning object. We basically need to spawn object from spawn actor from class. It's static mesh actor. And we need to pass variables from our preview mesh to spawn actor. So let's drag preview mesh, get actor transform, pass it to spawn transform. The actor will be spawned. Next, we need to set static mesh in static mesh component. And we need to take mesh from preview mesh. Get static mesh component, get mesh. It would be also nice to save the spawned actor to the array so we can do our merging later on. So let's add another variable, call it spawned actors, type static mesh actor, and make it an array. Drag it and add spawned actor there. Let's also do a short cleanup, and in the end, let's clean this array. Just clear. Forget to compile and save because sometimes things crash. Let's check how our tool is working. We can press left mouse button to spawn actors. Not that surprising, but it's something to start with. Problem is there are a lot of actors already, and we don't really need them. We want the tool to be automated and to make one actor out of our generation. So let's proceed with that. Next thing we're going to handle is property sets, which is basically a set of options and parameters for our tool. For that, we need to create another asset. Let's go to Blueprint, the set, and this is Editor Scriptable Interactive Tool Property Set. Naming is amazing for these things. Call it garbage generation property set and open the editor. Property set has several benefits. First of all, we can add events here and expose them to our tool. Second, we can store variables here and use them through different tools, save and load them, and so on. So for now, let's add an array of static meshes which we're going to use to spawn our items. We need 3 arrays, ground meshes, type of static mesh, would be our assets, and array. We can copy it with Ctrl and D. This will be small meshes, and the next array will be large meshes. We're also going to need some kind of switcher for our mode, which we're going to choose like ground mesh, small mesh, or large mesh. For that, I made an enum. Going to make another one, so I'm just going to show you how it works. This is a simple enumeration with ground garbage, small garbage, and large garbage. 3 types. You can always create them blueprints and enumeration and just add fields there. So we're going to add it as a variable to our property set. Let's call it current mode and give it type garbage placement mode. But we need to connect our property set to our generation tool. For that, we also need to add it here. You can use that property set of type. Select it from created properties. Give it identifier if needed. But basically we need just to edit and save it to variable if it's created. Let's call it settings. Save it on success. Compile, save, go to demo map, and when we enable our tool, We see nothing here. That's great. Because to be able to see things, we need to expose them to make them public. So let's expose them, get back to our editor, and everything, almost everything works fine. Current mode should be not an array, but a single variable. Compile, save, demo map, perfect. Here we can even add some items, but we're not going to. So let's look into second option, which we have here is exposed events. Let's create custom events. Let's call this event merge and another custom event. Add meshes to category. Compile, save, go to map. Nothing changed here. That's okay. Because to be able to see these events, we need to enable column editor. After that, compile, save, demo map. We now get buttons, which are connected from property set here. We're going to handle the actual merge of meshes in our main tool. So from this button, we only need to make an event. Let's use event dispatcher and call it on merge requested. Bind to that event from our tool. So basically this will be just a shortcut for that. As for meshes to category, we can use node get selected assets of class probably. Why not? We can use static mesh filter here. So basically, this will get the selected assets in the content browser and do something with them here. We need for each loop for selected assets, and we need to cast it to static mesh. Because as you can see, this is an array of objects, and we don't directly know if it's static mesh or not. With that, we need to add this static mesh to one of the required arrays. To do so, let's make a switch based on current mode. This is like option 1, or we can go the other way around and just use add unique and target array. We use select, insert current mode here. Let's remove the switch. It will be way more accurate. Drag our arrays from variables. Ground mesh goes here, small mesh goes here, large goes here. This and this. So our current mode is selected. We can't switch it like from keyboard now. That's the next step. But our meshes from the content browser will be added to the required array. Let's try it. Have this folder with meshes. This is our current mode. So ground garbage. Let's pick 4 boxes, press button and works. You can pick another bunch of assets, switch mode, well, it's okay, and edit. No, not by that button, this one. Yeah, it works. We can see at least 2 problems now. First of all, when we get back to our tool, everything disappears. That's why we need to save and load our preset. Second problem is that we can't switch modes from keyboard, and we have to pick everything here, and well, we're going to be lazy and optimize everything and automate everything as much as possible. That's the point of the tutorial. So let's go and handle our problems here. I think we can first tidy this up a bit. This will be like, okay, initial setup, like our first step. Will be mouse handling. To make it even better. This part is mouse handling. Quite nice to organize your blueprints so you have any problems with it later on. This will be our preview mesh section. Handling, and this is our property set handling. So with property set, you have to do two things. First, try to load the settings if there are any. Sure, load mod restore property set settings. Passing here our property setting, save key settings, save. Okay. Hover on this event, you will see that it will have no effect unless a save property set settings has been called on a compatible property set. So there is a slight problem with it. If you change something here and compile it, well, settings are restarted. So keep that in mind. You can use probably Unreal default save system to mitigate this issue or store the settings somewhere else. But for now it works like that. Next thing we need to do is to get some event from our property set so we can bind to it and actually save the settings. So let's go to our generation property set, add new event on mesh update, call it when we add some meshes to our categories, compile, save. I just found out that we have naming problem, so let's go to our asset and rename it from garbage to garbage. Next, we can go back to our generation tool, get our settings, custom to garbage generation property set. Do it either here or here, it doesn't really matter. And if it's okay, we can bind on update, on mesh update. Let's call it update binding. Custom event, handle, mesh update. And we need save property set settings here. Copy our settings, insert it here, copy key from settings save. And this will be it for saving. Let's check it. Spawn garbage, nothing here. Let's add another pack of assets. Switch our category to small garbage. Pick these items, add meshes, complete. Spawn garbage now opens, everything works fine. But there is a problem. If we go to our property set, compile it, save it, launch our tool again. You can see that there are no meshes here. It's a bit inconvenient, but for now we are going just to live with it. So let's just finish working with property set. So we're not going to touch it anymore and compile it. And by doing that, we're going to keep our settings intact. As another option, you can just fill the array here, or you can fill array here with a tool and copy the default values to property set if you like to. But for property set now, we need only one more function called get random mesh. We need output of static mesh. Let's call it out mesh. Make this function pure, so it doesn't have any execution nodes. And we need to get some random mesh from our arrays. Let's get random, return it, disconnect array from here, and use select node. Use current mode as index and attach arrays here. So now, based on our mode, we'll be selecting random mesh and returning it. And that's it for our property set. We can close it. Don't need to change anything in it. It will be saved and will be restored. Now we need to handle the mode switching and actually getting the meshes. Let's start with mode switching. We need in our behavior add single key input behavior. Let's tidy this up a bit more and connect this here. So this button will change our behavior, our mode of placement. Let's use key 1 for that, key 2, and key 3. Connect everything and add custom events to handle. Winch to ground mode. Winch to small mode. Custom events switch to large mode. And we need another function. Let's make a function switch placement mode. Input variable will be our garbage placement mode. In mode. Let's get our settings, cast it to garbage generation property set. Now what? Let's just change the type. Okay. Garbage generation property set here. So we don't cast it every time. Now we need to cast it only once on our property set handling. So cast to garbage property set, connected here, disconnect this one, connect here, reconnect here, remove this one, connect here. It's way better. our settings is of correct type and we can use it directly. Maybe some a bit more. File save, everything is perfect. For this, we need just to call our switch placement function. It will be ground garbage, will be small garbage, and this will be large garbage. Let's call it mode switch handling. Let's go into our switch placement mode function. First, we need to update mode in our settings. Set current mode. Next, we need to select random mesh from this category. So for that, let's add another function. Call it select random mesh. What we need to do here is to get our preview mesh, check if it's valid. If it's valid, let's make set static mesh. And we need to get our settings and get random mesh. This is the function which we created before. Also, we need to add rotation to our mesh. So let's add another function, rotate preview mesh. Just get our preview mesh, check if it's valid again, and set actor rotation. Let's split it and make the rotation random floating range 1 to 360. Let's get back to select random mesh and call our rotate preview mesh here. File save. Let's get back to switch placement mode. We switched mode, we saved it into settings, and now we can select random mesh. Compile and save. So now after pressing switch mode, we will get the new mode in our settings and the new mesh will be selected and assigned to our preview mesh. Check that, we need to add some meshes. Again, to our arrays. So let's select boxes. We're in ground garbage mode, add meshes. Select these things, switch to small garbage, add meshes. And select big items, switch to large group and add meshes. Now when we press 1, we are switching to this mode. The mesh is selected randomly and rotated randomly. Button 2 switches to small meshes and button 3 switches to large meshes. Let's check how everything works for now. Placing items with left mouse click. Let's hide this part and add this large box here. As you can see, after placing the item, we have the same item selected, so that can be adjusted. Now let's complete it. And they are not merged yet. Let's get back to our generation tool. By using separate functions, we can easily modify the behavior. So let's go to our spawn object. This is where we spawn static mesh actor, add it to array, set static mesh. After that, we can just call select random mesh. So now we can see how it works. When we place actor, one is selected automatically. You can actually pile them really quick without any extra input, which is very convenient. Let's go back to generation tool. We need another function to merge our actors. Let's call it merge. Basically, we need to select all our spawned actors and merge them into one static mesh. To do so, we need to do two things. First, we need to create unique new asset path name. So we can pass that parameter into merge function. As for asset folder path, let's use game merged assets folder, and base asset name will be garbage. This function will create a path for asset, basically a name, which we can use. If it succeeds, we need to call merge static mesh actors from Static Mesh Editor Subsystem. So let's get the subsystem first. This one. And from it, we can call merge static mesh actors. Function takes two arguments. First one is spawned actors. That's why we were saving them to array. And second one is merge options. Let's make new structure. Here we need basic package name and new actor label. Let's give label garbage, rename components okay, destroy source actors okay. You can enable it or disable if you don't want that behavior. And we need to make base package name. Can do so by using append, copy the path from here as a folder, and get unique asset name here. By doing so, we can get base package name, which will be checked by Unreal Engine. Also need this structure, so let's make it. You can see there are a lot of different settings. You can play with them. In our case, I think everything should be by default. After merging actors, like all spawned actors will be destroyed, source actors, but we also need to clear the array of spawned actors. So let's go clear. File save. And now we need some way to call this function. If you remember, we add the merge button to our property set. Doesn't do anything, but it fires the event that the user requested merge. So let's utilize it. Go to generation tool and our huge initial setup here. We probably need to add another sequence. Drag it here. Get settings and bind merge on merge requested. Create event merge. We can just bind it directly to our function. Handle merge. Compile, save. Save everything. Let's go to spawn garbage. Okay, let's create some garbage here, some bottles, coils, whatever it is, probably big box. And when we press merge, we can see that we have one static mesh actor with almost correct pivot point. It's saved in our folder matched asset with unique name. You can check it as a static mesh. You can export it to your 3D editing software. And if we were using texture atlases, there will be only one material for this kind of asset. But as long as it's a demonstration, I'm using 4 different materials. That's actually it for most of the things that I wanted to show you, but let's check one last thing. You can use editor widgets to create separated UI for your tools, which is another amazing thing which you can do with Scriptable Tools. Tidy this up and add another sequence. Go here. Basically, what you need to do is to create widget. I already made some demo widget just to demonstrate how it works. After widget is created, we save it to variable widget and call setOverlay widget. Make it draggable, so it will require additional handling in the widget, but it's a good addition to the system. Compile, save, go to our tool, and now we have this widget. Let's dive into it and see how it works, just to show you the basic structure. It's just a vertical box with text and button. When user presses a button, it fires the event on merge clicked. And we can go to our widget here, to our tool, get our widget, bind on merge clicked, use create event, and call merge. So this way we can make user-friendly UI with full UMG support and specifics, and it will forward the event from here to our tool and merge the actors. Let's try it. And it's done. Another nice looking, well, kinda garbage bag. So to summarize, today we created a scriptable tool which allows us to generate garbage piles from different assets and merge them together. We did some handling of mouse and keyboard events. We worked with property sets. We handled merge through using Static Mesh Editor Subsystem. And we even tried attaching widget and handling input from widget to Scriptable tool. I hope this tutorial was useful for you. You can find the project files in the comments and feel free to ask any questions. I will try to help you as much as I can. Thank you and see you